Okay, so we've got an example to do with pulleys. We've got particles A and B of masses 0.4 kilograms and 0.8 kilograms connected by a light inextensible string. A lies on a rough horizontal table 4.5 meters from a smooth pulley at the edge of the table. The string passes over the pulley and B hangs freely with the string taut 0.5 meters above the ground. Friction of 0.08 g opposes the motion of A. The system is released from rest. We're going to find the acceleration of the system, the time for B to reach the ground, and the total distance travelled by A. So, as always, we want to start with a nice clear diagram. So we've got a table, and we've got a pulley at the end. We've got particle A here. That's got a mass of 0.4 kilograms. And then we've got string hanging over here. And then B is here. Let's move the cat. Okay, so B has got a mass of 0.8 kilograms. And we want to label all the forces that are going on. So obviously the weight of B, 0.8 g, is going to be down here. We're going to get tension here going vertically upwards. Tension pulling on A, which is equal and opposite to this bit. We've got friction acting on A, which is 0.08 g. The other forces acting on A aren't going to make any difference, but we'll label them. We're going to get the weight, which is 0.4 g, and a reaction force, which would be equal to 0.4 g, in fact. Okay, so those are the forces that we've got going on. Perhaps we ought to label the acceleration, which will be this way. Similarly, this way for A, for particle A as well. Okay, so we want to find the acceleration of the system to start with. To do that, we want to get two equations in motion, one for A, one for B. So that's really F equals ma. So think about the forces on A. It's going to accelerate towards the edge of the table. T is pulling it that way. The friction, 0.08 g, is opposing that. And that's equal to its mass, 0.4 times the acceleration, which we're calling A. Then for B, 0.8 g is pulling downwards. The tension is opposing that. And that's equal to the mass of B, which is 0.8 times by A. So we want to eliminate T in there in order to find the acceleration. So we'll do that by adding together the two equations. So if we add them together, the T's will cancel because we've got plus T and minus T. So 0.8 g minus 0.08 g is 0.72 g. And then we've got 0.4 and 0.8 times the acceleration, so that's 1.2 lots of A. So therefore, to get the acceleration, just divide by 1.2, which would give us 0.6 lots of G, which is equal to 5.88 meters per second squared. Okay, so part B is asking us about the time taken for B to reach the ground. So if you think about what's going on with B, it was 0.5 meters above the ground. So B was here. It's got to drop 0.5 meters in order to get to the ground. So it's really a kinematic equations question. So we've got S needs to be 0.5. It's released from rest, so U is 0. And we've got an acceleration of the 5.88 that we just worked out. And we're trying to find T. So the equation that connects those is S equals UT add a half AT squared. Substitute those in. So 0.5 is 0 times plus half of 5.88 T squared. And then we just need to solve that to find what T is. Okay, and that comes to this number 0.4123930. 494, or about 0.412 seconds. Okay, and then the final part is asking about the total distance travelled by A. So in that initial phase, when B is falling, it's going to be accelerating at the same rate, time will be the same, start with the same initial velocity. So in that initial phase from when B goes from here to the ground, A is going to have travelled the same distance. A will have travelled 0.5 meters. After that, the only force acting on A will be the friction. There won't be any tension in the string anymore. So when B hits the ground, A keeps moving, the string's going to go slack. So that means we're going to get the total distance travelled is going to be 0.5, which is the distance from B to the ground, plus whatever it travels in the rest. So if we do another quick diagram of what's going on there, so particle A, the only force horizontally acting is here, which is 0.08 g. So it's going to be decelerating. So if we write as an equation, minus 0.08 g is equal to the mass. So the mass of A was 0.4 times its acceleration. And that's going to give us an acceleration of minus 1.96 meters per second squared. So we've got A is minus 1.96. We've got final velocity will be 0 because we're slowing to a stop. We're going to have to work out something else here, aren't we? Because at the moment we don't quite have the information for it. We're going to need to get the velocity of B when it hits the ground. That will match the velocity of A at that point. So we're going to have to work out that before we can get anything else. We've not quite got enough information to be able to do that. Okay, so we're going to have from before back to this bit. If we use these numbers, we can be able to work out V. So using this bit of information, we can find what V is. Okay, so the acceleration was 5.88, S was 0.5, U was 0, V is the question mark. The equation that connects those is V squared equals U squared plus 2AS. So we can substitute in to find that. So V squared would be 0 plus 2 times 5.88 times 0.5. In other words, V is going to be the square root of 5.88, which is 2.424871131. That's then the initial velocity for the next phase of motion. So this is a bit of an aside. So the final velocity at the first bit, so from B falling to hitting the ground, then we sort of reset things. And that's now the initial velocity for the next part of the question. So we've got these three things. We're trying to find the distance travelled, which is S. And so the equation that connects those is actually the same one as here. So V squared equals U squared plus 2AS. This time with V is 0. Then we've got that number we just worked out as 2.424871131 plus 2 times the acceleration times by S. Sorry, wrong acceleration, it should be minus 1.96 there. That's the new acceleration that we're using. Then we just need to solve that to find what S is. Tidally, that comes out as being S is 1.5 meters. So the total distance travelled is that 1.5 plus the 0.5 we talked about earlier on. So total distance is 2 meters.